So this is not a real AP problem. It is out of a practice book, one of those, those like prep books. It's not out of the one you're going to get. But it was such a neat one that I thought it would be good for you to see. It uses almost every theorem you are supposed to know. So it's probably the reason it hasn't been a real AP problem is it would probably be a pretty low scoring one, although they have some of those sometimes. Is it possible for x equals 3 to be a vertical asymptote for f? Any ideas? X equals 3 is not on the table, so we're asking to make an assumption. Well, why not? I mean, why couldn't there be an asymptote there? What is a vertical asymptote?
Like nothing touches it.
Okay, a place where you have undefined values. Can there be a vertical asymptote at 3?
No.
Why not? F of x is continuous. Well, f double prime is continuous, which means, remember, differentiability implies continuity. So if f double prime is continuous, that means f prime is differentiable, which means f is differentiable, which means, trace that all the way back. You can't have a vertical asymptote there. Okay, and I'm going to shortcut some of these explanations just for time, since we actually do have something to learn today. But is it possible for y equals 5 to be a horizontal asymptote? So let's ask the question, what's a horizontal asymptote? It's a line that we level off to as x approaches infinity. Yes. Right? Do we know anything about this function as x approaches infinity? So is it possible? Yes, it is possible. Do I know? No, but is it possible? Yes. So B is yes. It's talking about a limit as x approaches positive or negative infinity, and I don't know any information past 4 and past 0, so could be. Very well could be. Show that there is a point C in the interval 0 to 2. So we're talking about this interval here, where f double prime of C is less than 0. Oh, is it just f prime?
Nope, f double prime.
It's f double. This one right here. C.
Not just one?
No, there's 2 there. It's okay. On the AP exam, you'd be able to see it better. This one is 1. Almost the exact same question. So show that there is a point, which it did help me out a little in saying, show there is one. So they're not leaving a whole lot to question. They're saying, hey, there is a point. How do you know that? What are the 2 theorems when we see a question like this that should pop into our head? The mean value theorem and the intermediate value theorem. I would first try intermediate. It's easier. However, on the intermediate value theorem from 4 to 1, is there any guarantee that I drop negative? No. So I need to go back and try the mean value theorem. How do you use the mean value theorem? Good. Now, since I'm trying to show f double prime of C, right? I need f prime, right? So I'm going to do f prime of 2 minus f prime of 1. Yeah, okay, if I just go ahead and do 0 minus 2 over 2 minus 0, which is negative 1. Right? So there is guaranteed to be a C between 0 and 2, where f double prime equals negative 1, which is negative less than 0.
Use the x. You wouldn't use the f of x.
That's right. Mean value theorem. And so you would say, for explanation purposes, what do I need to say anytime I use the mean value theorem? Continuous and differentiable. Which is it? F double prime is continuous, so everything before that is continuous and differentiable. So F double prime is continuous and differentiable. Therefore, by T, there exists a C in 0 to 2 such that F double prime of C equals -1, which is less than 0. There are other ways to word it. Important stuff. Continuous and differentiable. Show that there is a point C in 0 to 2 where F prime is less than 0. Again, they're telling us there is a point. First thing I would try is intermediate value theorem. Doesn't work for me. Second thing I would try is mean value theorem, right? And what am I trying to show? That F prime of C is less than 0. And so I would go to 5 minus 1 over 2 minus 0. Isn't that positive also? So I am in trouble. This is the most challenging problem that I have probably seen in this topic anyway. Because I know there is one. It says show. Mean value theorem and intermediate value theorem failed me, so I've obviously got to get creative at this point. So I want to think a little bit about this function. If we look, F prime is 0 at 2. What does that mean 2 is? It's either a max or min, right? It's a critical value. Since I don't know values right before 2, or if there are any more critical values before 2, the best test to find out if it's a max or min would be the second derivative test. If I glance over to the second derivative at 2, it's positive, right? Does that mean that 2 is a minimum? What has to happen right before a minimum on the first derivative test? What has to be negative? The first derivative, right? So this is a crazy hard question. Here is which this is actually all the answers, but here is D's explanation. Note that since F prime of 2 is 0 and F double prime of 2 is 1, which is greater than 0, f of x has a local minimum at x equals 2. Then, by the first derivative test, that means f of x must be decreasing just to the left of x equals 2, and so f prime of x would have to be less than 0 just to the left of 2. So, on the interval 0 to 2, there is somewhere that the first derivative is less than 0 by the first and second derivative test. So, very interesting problem. Probably will never see one that hard, but really got your brain going this morning. So, I remember the first time I saw it, it had my brain going. So, okay, so today we're going to look at what are called Riemann sums. Riemann is the name of the guy who came up with this idea. Yesterday we found areas under curves, but they were all geometric. Triangles, rectangles, squares, circles, things that we could find the area of. Well, obviously, we're going to want to be able to find areas of things that we haven't found areas of before, like parabolas or cubics or anything. So, how would we do that? Well, a good estimation. How good? Well, we could get really good if we wanted to. We're going to use rectangles and or trapezoids to estimate the areas. So what I have down here, I have 4 pictures. And they are 4 different approximations. They all have their benefits. right rectangles are rectangles where the height of the rectangle is on the right-hand portion of the curve. So if I look, and I am making a rectangle. No, we're not starting at 0. I was about to say I'm missing a rectangle here. So my rectangle, the height of the rectangle is determined by the right endpoint. Does everyone see that? Right endpoint of the rectangle. Left rectangles, the height is determined by the left-hand side of the rectangle, the height of the curve at the left-hand side of the rectangle. Midpoint rectangles, the height is determined by the middle of the rectangle. And trapezoids, instead of using rectangles, I use 2 different heights to make 2 different bases of a trapezoid and find that area. Turns out that the trapezoid, well, I'll tell you that in a minute. Let the cat out of the bag. Anyway, so we have 4 different approximations. Could we do this with any function? Right now, there's 4 rectangles here. How would you get a better approximation anyway? More rectangles. Maybe infinitely many rectangles. Calculus. We'll talk about that another day. But for today, the more rectangles, the better approximation we'll get. The error would go down every time we add another rectangle. Trapezoids, if you are doing a small number of rectangles, trapezoids or midpoint rectangles are going to give you better approximations than right or left-hand rectangles, which makes sense most of the time. Okay, so today we're still going to just be finding area, and we're just going to use rectangles. We are going to have error in that because we're going to have an over or under approximation, which we'll talk about. So I want to approximate the area underneath the curve x squared plus 3 using LRAM, which stands for Left Rectangle Approximation Method, with 2 rectangles from 0 to 4. Is that going to be a very good estimate? Probably not. So I'm going from 0 to 4. So I'm going here. And I'm doing 2 rectangles. How wide does that mean each rectangle is? 2 units. So I have a rectangle that stops here and a rectangle that stops here. I am basing my height on the left-hand endpoint of that rectangle. So this is the left-hand side. So the height of that first rectangle is determined by that left-hand endpoint there. The second rectangle, again, I'm going to use the left-hand endpoint for the height. Any questions so far? There will be a formula that we'll learn for LRAM and RRAM. But I will tell you, if they ever ask you this on the AP exam, at most they'll do like 5 rectangles. And I will have people get on the AP practice test and go, I don't remember how to do Riemann sums. What am I going to tell you to do? Draw a picture. It's just area. Riemann sums, in the way that the AP exam will ask them, is never difficult. You're just going to find the area of about 5 rectangles, if that, sometimes 2 or 3. So as long as you can draw the picture, you're good. What trips students up is we'll learn a formula which will lead to higher level concepts, which is great. But going back to Riemann sums, when you are asked to do a Riemann sum, don't hesitate to draw a picture. Just sketch it really quick and find the area. So can we find the area of this? What do I need to find to be able to find the area? The base and height. And I know the widths of both of these were 2. So the only thing I need is the height. Well, how would I find the height? The function, right? So I have 2 times this point here, isn't that f of 0? Everyone agree that that would be f of 0? Everyone see that? Plus 2 times f of what? 2. How would this be different if I used a right-hand rectangle? Instead of 0 and 2, what would be there?
F2 and 4.
Good, f of 2 and f of 4, because I would use the right-hand side of those intervals. So you can see how we could come up with a formula momentarily. Maybe probably tomorrow. We'll see. F of 0 is 3. F of 2 is 4, 5, 6, 7. 20. Is this an over approximation or an under approximation of the actual area? Under. How do you know? Because it's below that curve. There's some gaps in there. That's something AP will ask a lot.
So when you do the base can always be the same for all of them.
Good question. For a Riemann sum, yes. Now later we'll do some table problems where the base is not always the same. But if you're making the rectangles, you will always make them the same width. If you're choosing them, it's easier that way. There will be times when that's not an option, and so we'll have to work with what we're given. Right rectangle with 4 rectangles from 0 to 4. So I'm going from 0 to 4, and I'm drawing a right rectangle. I'm going to choose the right-hand endpoint, and I'm going to do 4 rectangles. Does everyone know why I'm doing 4 rectangles? Said 4 rectangles from 0 to 4, so they're each 1 unit in width. Again, when these come up on an AP exam, don't hesitate to draw a picture if you get stumped. So each one is 1 unit. So I'd have 1 times, and I'm just going to, since, like Kelsey said on this, they're all the same size, I'm going to go ahead and just factor the 1 out. Are y'all okay with that? It's 1 times everything. F of what? 1. F of 2. F of 3. And F of 4. If this had been a left rectangle approximation, instead of 1, 2, 3, and 4, I would have picked 0, 1, 2, and 3. Very good. F of 1 is 4, is that right? F of 2 is 7. F of 3 is 9 plus 3, 12, is that right? And 16 plus 3, 19. Add those up. And what do you get? 11, 23, 52. Is that right? I should check. 42. Okay. Over or under approximation? So we know the answer somewhere between 20 and 42, the actual area. And we could continue to get closer and closer and closer and figure that out, couldn't we? Okay, midpoint rectangle. 4 rectangles from 0 to 4. We are going to pick up our calculator to actually do the math, but we're going to set it up first. We're going here, we have rectangles. We could totally do the math without a calculator, but just for time purposes today. I'm going to pick the middle point to determine the height of my rectangle, correct? So what is my first height of my rectangle? Good, a half, right? Does everyone see how I know that? The second one, what is the height? Determine 1.5, right? F of 1.5, because we're doing the middle of the rectangle interval. Is this hard? No. Can it get tedious? Yes. Remember that 2 months from now when we're reviewing for the AP exam. I have people all the time who come back and say, Riemann sums are so hard. They're not if you'll draw a picture. They are if you try to do it all in your head without a picture. So keep that in mind. Draw pictures. I'm about to show you a calculator program that does Riemann sums for you, but I show it to you with great caution. On the AP exam, they will never ask a Riemann sum question that you can use it on. So it is for speed and us working some homework problems just because we want to, add things up quickly. But keep in mind, you need to be able to draw triangles all by your very own self, or rectangles, and you need to be able to find those areas, which I think you can do no problem. 2.5 and 3.5, everyone agree? Okay. Now, let me show you a program. If for some crazy reason they ever put a Riemann sum question on a calculator part of a test, which they won't. I'll just let you know they won't do that. But if you go to Program REI2, I'm going to show you what all it will do. Our function was x squared plus 3, is that right? The lower bound was 0, the upper bound was 4, because we're on the interval 0 to 4. The number of partitions is how many rectangles or trapezoids or whatever it is we're making. So in this problem, we're making 4. Then it will bring up a menu, and it'll ask you what you want to do. Most of the time, your answer will probably be see all for shortcut's sake. But I don't want to do that right now. I want to do individual. And which one did we just do that we want the answer to? Midpoint. So I'm going to go down to midpoint sum. If you do all, it will draw the picture for you. It's nice. And so it will draw the picture. And then if you push enter one more time, it will tell you that that sum is 33. So pretty cool program, does amazing things. AP knows it's out there, so they don't put these on calculator problems very often, if ever. But it's good to know that it exists. Like I said, you will always want to be able to draw the rectangles. Okay, let's do a trapezoid. Again, I'm going to do it by hand because you need to know how to set it up. We'll look at the calculator momentarily. From 0 to 4, and I'm going to make trapezoids. What that means is I'm going to have 2 different heights at every interval. Does everyone see how the trapezoid picture works?
What would be the problem if you didn't use the calculator?
This, just on the non-calculator part of the test.
More like on the AP exam.
It may ask you this exact question. It just would be non-calculator. They will always keep the number of partitions small so that you're not doing 100 rectangles. The reason we're going to use the program is we're going to do some explorations where we do like 100 rectangles. We don't ever want to do 100 rectangles by hand. And the AP exam would never ask you to do 100 rectangles. But they may very well ask you any of these questions on this slide without a calculator. And if they ask you this one, you go ahead and find the values. The wonderful thing about AP, don't do this on your homework. But on the AP exam, if you leave the answer like this, they will take it. So as far as addition goes, you can just leave it as a big addition problem. So they can ask you any of these. Okay, the width is 1. That's actually the height of our trapezoid, isn't it?
So the very first one is 1, 2, like maybe 4 trapezoids.
Yes. Did I not draw one there? Thank you. So remember, the area of a trapezoid is 1/2 height times base 1 plus base 2. On this picture, the heights are the function values, the base is the width of the trapezoids, right? So I'm going to go ahead and factor out 1/2 times 1, because every trapezoid is 1/2 times 1. Does everyone agree? The width or the height's 1, the formula is the 1/2. Base 1 would be f of 0 plus f of 1. Base 1 plus base 2 on the first trapezoid. I'm going to switch colors so you'll know that I'm switching trapezoids. The second trapezoid will be f1 plus f2. f of 1 plus f of 2. Plus signs are not wanting to. My third trapezoid will be f of 2 plus f of 3. Everyone know where I'm getting this? And then my fourth trapezoid will be f of 3 plus f of 4.
Is that going to give you the complete accuracy?
No. It will never be perfect. Not with 4 rectangles. It will get closer though, right? This will be the closest. What is this value? 34? How did he do that so fast? Probably use the calculator program, I'm guessing. Trapezoid set of midpoint has all of them you could use. Anyway, this is also the average between the right and left. Wouldn't that be the average between the right and left? Because isn't that what a trapezoid does? So the trapezoid method will give you the average of the left and right remarks. Okay, I'm going to go ahead and pass out your homework. We are not finished with the notes. So if you come to something you can't do, wait till Monday. This is due on Wednesday. This is due on Friday. So, it's not long, it's just that you have more. Don't get at all stressed if you can't do it. I want everyone to do number 1. I want you to do number 1 without the calculator. I want everyone to do number 1, or you come back tomorrow and I want it without a calculator. No, not do Friday. So tonight, as you're not doing your homework, you're not going to have a lot. Even if you have it, the whole worksheet, it's not long. You can study for the date that you can start working on that. This will be due on Friday. We'll finish.